Thanks, Debs. And then just to remind you that this course from Steve Hoberman, Master Data Models, got nothing to do with building data models for master data management. It certainly helps you to, but that's not the focus. The focus is on how to model relational, dimensional models, even some links to JSON, MongoDB, and elements like that. Okay, and Veronica will be running that one. All right, so just moving over to my slide last week, or my deck. Thanks, Debs. Thanks again. Okay, so abstraction, when is it needed and when is it dangerous? Debs, I just want to check, were you able to post our recording from last week? Is that recording live?
The recording, it did happen. I haven't posted it yet. I don't think I've gotten a write-up for it yet.
You have. Okay. All right. So as part of that write-up, what I was saying was that when I was doing development, I was writing communication code for the banks. 86.25, NetBIOS, async. I was writing a whole lot of this code, and we were writing it in C. And shortly thereafter, sort of OS2 fell away. We then went on to C++, and that was a bit of a mind blow for me in terms of how different it was. And it was basically a complete paradigm mind shift. And I'm wondering how many of the call could actually recognize that or were part of that. And the other thing is almost like this big data analytics. That's a similar type of scenario. Now, when I went into object-oriented programming, this was amazing. The whole concept of designing the class hierarchies and the class structures and also abstraction. I think it almost created, I became an abstraction junkie. And then everything I could do, because of the flexibility and because of the extent I abstracted. And it wasn't really, and it did not just in class designs, but I carried that over into my data modeling. And when I went to Steve Hoberman's course to do the course and actually become a trainer, one of his slides was this thing of the dark side of abstraction. And I hadn't really spent time thinking about it because I was so confident abstraction was an amazing thing. But after lots of discussions with him, he actually did several ways how dangerous this could be and how it was an overkill. It actually, in some cases, created a development cycle. It gave a lot more responsibilities back to the developer to do data quality checks and things like that. When I finally sat down and looked at all the challenges, it's like, oh dear, I really got to be careful. And I must also admit, because I'm quite a few master data projects, and in master data it was great. That's that party model, all those things. That was abstraction on steroids, which I enjoyed. I really liked that concept, and I do believe it works in things like master data. But in sometimes on a relational data model, I think we actually cause some damage. And I think that's one of the things that we have to check ourselves is, do we clearly understand the problems we create with abstraction? And in some of the talks we had yesterday, one of the things I realized was that we need to be clear about what abstraction we're talking about before we say it's good or bad. Sometimes we just say it's bad, but then other times we know that this is really important. But then we must make sure we apply this thing from Steve Hoberman, which is called an abstract safety guide. Whenever we do it, we pay attention to this. So this was the different areas that we could use it in. The process of taking away or removing characteristics from something. The use of shapes and patterns in a data model. that comes from sort of those reusable patterns and abstract art. Then we also have simplicity, or the freedom from representational qualities and details. That's almost abstraction for presentation. So that's what that conceptual model does. It simplifies, it reduces it to its minimum so that people can understand it and you can communicate. And the last one was the act of considering something as a general quality or characteristic apart from the concrete realities, and that's that subtype and supertype. Nice again for the conceptual models and displaying it to business. Unfortunately, you can't implement it. And then we get into that those great CDMP questions, partitioning or absorption, or partitioning is roll down and absorption is roll up. So which approach do you choose? And again, we say this to the DBAs, we don't mind which one you choose. Just tell us why you chose it. What was your reasoning for absorbing or partitioning? What did you see? What was the understanding? Okay, so this is related to data models. So we did the essential concepts last week, and I don't want to go through that again. I want to focus this week on abstract for specification. Okay, now one of those hard things that you do is, for example, the first thing you do when you're preparing a talk like this is try to go to Google and say, okay, what is Google telling me? And here is the results of the Google search. And this one was, if you just, its abstraction enables modular programming by hiding the details of implementation. Okay, so this wasn't what I was talking about. This was not what I was trying to achieve. And I basically went through all of these different slides, and I couldn't really find what this abstract for specification was all about. So I decided to, as part of this discussion, to go through the process of elimination and definition, almost the same way that you would do on a business glossary, and see what I defined abstract for specification is. And I'd love for you to get some comments to see what we're talking about. But first of all, I'd like to basically say that we're not talking about this scenario where I hide implementation details in a coding module. That's not what I'm talking about. I'm talking about the levels of specification. So the business requirements document, then it can go to a functional document specification, non-functional, technical, all these different levels. And it's more about the process of specifying. And I'm hoping if any of you have looked at the V model in terms of that. So Gaucher, yes, I actually got a chat GPT definition. So just to show you quickly, there's my chat GPT definition. And I like it. I like what it's saying, but I had to go some steps back before I went into chat GPT. So here is first of all, before I wanted to just focus on the specification. Before I go to abstraction by specification, do we all understand what specification is? And here's the Oxford definition. It's an act of identifying something precisely or of stating a precise requirement. Great, this is now going in the right direction. It wasn't about hiding details of a module by doing interface programming. If any of you remember Windows COM programming, they had those IDLs, and first of all, we had to do an IDL, but the programs didn't know anything about the implementation. So that's sort of what Google was talking about. But I'm talking about stating a precise requirement and almost like a contractual type of scenario. Or Oxford also defines it as a detailed description of the design and materials that's going to be used to make something. Okay, great. So we're getting into a situation of, I can see now when I do a conceptual model, I then go at a certain level of a business requirement, conceptual model, logical model, physical model, database. And so I'm using it to make a database design, an implementation that will keep my data, that's going to hold all the data that I require. Merriam-Webster refers to this as a detailed, precise presentation of a plan or a proposal for something. Now, you can see that I've marked these in different colors, and we call these our 6 friends. And the friends are purpose, what function is it performing, who, what, when, where, and how. Okay, so the purpose is typically the why. So that's those 5 wives and a husband from John Zachman, and there's a high-level classification of the term. Okay, and typically whenever you see is a, then you know that's your classification. So that's what Merriam-Webster said. Then I went to Encyclopedia Britannica, and it says it's a detailed description of work to be done or materials to be used in a project, an instruction to say exactly how to do or make something, the architect's specification of a new building. The equipment will be manufactured to your specifications, and it's that first one that I'm really interested in, is the architect specification. And I'm sure you remember in John Zachman, he's got the audience, and the first one is executive, and they refer to that as planning. The next one is management, and the next one is architect. And so it's these levels of specification of the information that you need. And I'm hoping now you can already see the benefit of abstraction in this area when you are presenting your sort of what's or your data to an executive. Having big fancy data models is not going to help you, right? They're going to lose interest and they're going to disappear pretty quickly. So you almost start off, when you talk to executives, you start off with what some people refer to as a subject area model. Zachman refers to an inventory list, a list of business concepts. And that's what you'll present to an executive. I like to put visuals and icons and colors to help me explain, but that's each person to their own in terms of how far they go with it. Okay, so just maybe for myself to pause, ask some questions, for example, on Paul Bolton. Are you seeing what I'm referring to in terms of a specification? It's the levels of understanding or definitions before you get down to finally coding it. Are there any questions on that?
No, thanks, Howard. That's not helpful. I just was thinking of the specifications that we looked at or worked with from the NDMO.
Right.
And
Right.
a nice summary of what they wanted. And then they went a little bit further and broke it down to some tasks and subtasks.
Right. Right. So it's a nice analogy that you're using. It can even be a regulation or a standards document. That's at a high level what we need to do, and we need to find ways of now drilling down on that specification, but not losing touch with the specification. Are there any other comments? Gaucher, anything from your side? Are you comfortable with what I'm defining?
I specifically like the portion which says the architect's specification for a new building. So I mean, you can start with a picture on that, so you can create a make-believe building. So I like that portion.
Okay, fantastic. And Steve Hoberman actually calls that thing, he shows a picture of a house, a ranch house with a porch and a kitchen and a diner, and he basically says this is the high level requirement. At this level, this is what's important to me. Okay.
Howard?
Yes.
Could you use our SciPox level 1?
Or what you'll do, and yeah, you can do that. You could do that, but I think so. There is that visual presentation, but when you're building from a data modeling point of view, you're going to be using something like a conceptual model, right?
Okay.
So because, for example, English can be vague and misunderstood, and you're trying to get a precise definition, you're looking to build more of a model in terms of how this is going to work. Paul, and I'll actually show you that when we go to Zachman's data architecture, enterprise architecture, you'll see that it's not just data. He considers business processes, organizational structure, and when and where is going to happen and why.
Okay.
So, for example, you could also use the Zachman ontology to define a lot of what's done in policies and procedures.
Thanks.
Okay, great. All right, so now from that specification, here is taking that and breaking it down into single sentences that we may lean on and stand on. So I'm hoping you're also seeing there were quite a few sessions we've had in the last couple of weeks where people say, tell me what this business glossary is all about and how do you get these business definitions? And I'm just showing you one aspect of it. There was a suggestion in one of the DAME user groups to take a business glossary right from the beginning to actually define it, create a data model, understand the relationships, how does it link to a data dictionary, and then show the whole thread from the top to the bottom in that situation. Okay, so this is more part of writing the definition of the word specification so that I'm getting a clearer understanding. And you can see my thread or the logic that I'm using. So in those two ones over here, can you see we had two things slightly different? A detailed description or the act of identifying something. And there I've got those two slightly different elements, a detailed description and then this act of identifying something. And that's a lot of the times what we do with conceptual model. We elicit requirements. We even, in some cases, when we come down to logical, we then do some normalization, and in the normalization, we find entities that weren't always there, and associative entities and things like that. And so with all the way from first, second, third, fourth, and fifth normal form, we're finding more rules, we're identifying more relationships, and it's making that model a better understanding and more flexible. Okay. So these are the two things: detailed description, identifying things, the process, the elicitation of the core business concepts. And the why or the purpose of this detailed description is to state a precise requirement. And the colloquial term I use for a conceptual model is business requirements. A conceptual model represents the business requirements, and a logical model represents the business solution. That's when we start putting in attributes, we start to normalize, we start to understand the association. So we go from high-level motivation statements, for example, a use case. We then go into a business requirement, we document it more, and then we go into a business solution. And then the physical model will depend on the type of storage and where we're going to place all this data. So we could have multiple there, but let's not go too far. Let's just stick to specification. And then what does it need to describe? It needs to describe the materials used in a project, or as part of identifying it, it would be how do we build something? How do we create this data model to house and to build a data product for the use case that we identify. Okay. Now, that's one of the words. So can you see here, I've defined specification, but now I need to describe this verb, abstraction for specification. I'm just going to go back to our Google definition again. This one saying, enables modular programming by hiding the details. So yeah, there's part of it in here, but I'm not at the programming level. I'm not talking to developers. I'm talking to business people, and I'm trying to understand their requirements. So let's go back. What is abstraction for specification? And really to help you guys, I've used it on several projects now where I'm battling to get Google to give me an appropriate explanation, and ChatGPT does a fantastic job. So here is ChatGPT's explanation. So I said, please explain abstraction for specification to me. And it came back saying, it's a process of representing the essential aspects of a system at different levels without including unnecessary details. So ChatGPT does get a little bit long-winded, but that's okay. It's giving us the important elements. And then they go down, and so I've highlighted the fact that abstraction for specification is a process. Okay, great. And it's a process for representing or precise or identifying. Then we go into the purpose, representing essential aspects. What do we need to show? We need to show a system or a requirement at different levels without including unnecessary details. So please, when you're presenting to an executive, you really don't need all the attributes, all the relationships, all the cardinality, all of that stuff, all the normalization. They're gonna lose it with you, and we're gonna fall out the truck. Okay. So how do we do it? This is done by defining the objects and their relationships in a system and creating a system model that captures the essential elements. So this is what we're focusing on here. Okay, is getting the objects, identifying the objects, picking up their relationships, and then creating a model that defines the essential elements. And the next step is to specify behavior. Yeah, Isham, that's what I should do as well in terms of where it got it, but whether it has more than one, I'm not 100% sure, but I'll do that and see what it says. Okay, and then it says this process allows developers to create a more abstract representation of the system. So now what this statement is saying is that it first of all allows the development people, like the modular programming side, to simplify the interface or to create a simpler representation so that it could be communicated with people from business or higher levels. And so this is what we're doing. Almost this is like reverse engineering. If we were to reverse engineer from the database to a physical, to a logical, to conceptual, we would then try to understand what the business people would like to change, what's needed, what the extra part is needed, and then we would then be able to understand how to take that down to the concrete implementation or change that's required. So again, maybe just to pause for a while. Any comments on this definition and what we've identified? What's your feeling about that? Are you starting to understand the process of abstraction for specification? Why do we need to do it? And then, of course, we have to be, is it needed? Is it important? And then can it be dangerous? So yes, Goshe.
So my question is, so we as the guys that build this and need to sell this. So how do you sell this to a business client in terms of value? So what is he going to save? You know, that's the old question coming back to, so what is it going to cost me and why? What I'm gonna get in return?
Right. Okay. And Goucher, if you just let me answer that one a little bit later.
That's fine. That's fine.
When I talk about the V model, I'll actually show you how it's this process of starting with the essential aspects and then allowing us to drill down. And at each level, when we drill down to the next level of detail, we can have a corresponding test model that will use us to ensure that at this different level of audience, we are interpreting their requirements in the appropriate fashion.
Okay, I agree with that. Thank you very much.
Okay. So Martin asks, how do we call this kind of breakdown? Martin, this breakdown is we call it the 6 Friends of Writing Business Definitions, and it's a course that I've done with Mark Atkins. I can share the links and the recordings, and it's a way. We also find a way of teaching this, teaching people how to create business definitions, how to build a definition, how to then discuss it. And I'm going to take you through just a few more little slides for you to see the whole process, and hopefully you'll see even more benefit coming out of it. Okay, so here, this is what I was blown away when Mark and Terry showed me this. I said, finally, I can write my definitions in terms of single sentences, and B, I have a way of taking that complete definition and agreeing with the business on every single statement. Okay, so this is the typical process that we do. So we can say abstract for specification is a process. Are we in agreement? Now, and then we would have a debate, and we would come off these different options. Are we confirming that it's a process? And then we go to the next line. Yes, we agreed that. That will represent the essential aspects. Okay. And we then ask the question of, are we in agreement that that's an appropriate statement? And I'm hoping you see here that whenever I've gone into another color, that's a related term or object. Okay, so if I was to build a data model from this, I'm going to have two data elements here. I'm going to have abstraction for specification, and then I'm going to link it to process, and I'm going to link it to the other noun, which is the essential aspect. And the essential aspect will be a subtype of aspect. So there's going to be aspects. We're going to have essential aspects and non-essential aspects. So we're saying abstract for specification is about focusing on the essential aspects, and that determines on your audience that you're working on. Okay. That will allow people to create more abstract representations. Okay. That will specify system behavior and must be defined at different specification levels and must not include unnecessary details. It must define the objects, define the relationships, and create a system model. So here's my business definition that I've got. This is the type of thing I would put into a business glossary. And the very next step would be to saying, well, yes, you've got that definition, but I also need to understand its associations with related terms, essential aspect, representation, abstract representation, detail, necessary, unnecessary, essential, specification level, object, relationship, system model. So I'm hoping, Martin, you also see now how much detail we get out of writing these definitions, and that we can build a whole graph relationship of our business terms to be able to see how this term fits in. And Paul, I wanted to just chat to you quickly, because I know you've also been playing around with these glossaries and things, and just get some feedback in terms of how do you find the process of defining these definitions.
So Howard, as mentioned to you, I struggled a little bit with abstraction. You know, getting it right in my head, because you know, it's kind of like you're taking a bunch of terms and reducing it down to a single term. And I was battling with that, and when I was doing modeling and stuff. But when I was putting the glossary together, I really enjoyed the when you help me see, when you start looking at the term and you bring those terms, is a this,
Yes.
and you start building those relations there, starts bringing to life the definition.
Right. Right. And what we worked with Mark Atkins is actually using this technique even before you go to the glossary, and then even before you build the data model. So it's trying to, first of all, get an agreement. Is this what we define and mean by
Yes.
an abstraction for specification? Okay. And there you can start seeing the ISA and the different terms and the different presentations of glossary terms that you would be relating to. Okay.
Thanks, Howard.
All right. Okay, great. So hopefully we all see abstraction for specification. It is a process. It must represent essential aspects, and it's essential for the audience. Okay. So what we show an executive and what we show a manager, what we show an architect, what we show a developer, it all depends on the audience. Okay. It must demonstrate behavior of the system. And then we'll link this to the when we use Zachman, we'd link it to the how and all those different areas, and they'll pick up the who's and the hows. Okay, and we can talk at these different levels. Okay, we've also then got the fact that it should not have too much noise. Don't put too much information into a model that's not going to be appreciated, because they'll just stop reading. Okay, but the important thing is defining the objects or the concepts, the relationships, and the model and the dynamics in which this thing works. So that's what we're talking about abstraction for specification. Okay, so now let's get almost in terms of why do we need this? Why is this part of, and this V model actually comes from the SWE block, which is the software engineering block, but we use that in data modeling as well. Okay, so let's go to this. I also had I keep on using it to explain to people the process that we're going of extracting details and requirements from the business and getting to a point where we're taking on more implementation details so that we can start coding, right? At the end of the day, we've got to get to code, be it ETL code, be it C#, be it whatever code you're doing, you've got to get down to this coding. But what I like about this approach is to say, can you see right the top from understanding the requirements, going down to the next level of system design, architectural design, modular design, and coding, that for each one of these artifacts, you need a corresponding test level, okay, to confirm that you've done what was agreed and asked for, because you're going to get the people to sign off these artifacts, right? This is what this is all about. I do a Word document to build a requirements analysis, and if I don't have a corresponding test document that says that all these Word requirements have been delivered, the business never know. Okay, and so we need this constant mapping. And here's another explanation of it. This is sometimes used in the test models. They call it business need. This is for Agile. Business need, product vision, business analysis document, technical specification, technical design, unit specification. And so we validate on the way down and we verify on the way up. Validate, verify. And this process of abstraction for specification is when we abstract and we make it simpler, we're going up the chain, we're going up this hierarchy. Okay. And we'll be presenting at different levels of detail, okay, for the right audience to see it. Here's another layout of that. We talk about, I'm hoping everyone can see. Let me just go to my presentation just to make sure that people can see that model.
Yeah, the V with the blue and the yellow. Yeah, that's good.
Yeah. Okay, so there we're talking about a requirement design, a system design, an architecture design, the modular design, we code, and then we must have the unit test done. So our testers should be defining this at each level like this to confirm that we've got the corresponding sign off on the other side. So I really like to share with people as I'm not just abstracting for specification, but as I'm drilling down on the details to understand how we're going to implement, I must also have this corresponding test model that's happening in the background. Okay. And then we go from here to Agile development. Now, it's all about the V, but it's then just describing the different levels. So this one would be business need, product vision, the features of the product, the stories, the functional tasks in terms of the feature breakdown, in terms of what we need to deliver. And there we go up again, test-driven development, and we test that, right? So basically, the way this works is that before you start coding, you've got all the tests, and you code to meet the tests. And as you click off, as you'd say, done, 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 you are doing test-driven development. I'm hoping that people see how that works. And then we got regression testing. Are you breaking anything else? And then product owner testing in terms of fit for use, fit for purpose. And then we've got a business case assessment. There's that return on investment, net present value. Are we actually getting the benefit realization? Are we validating it? Okay, so the business need may define it now, and the way in which we validate this cost savings and revenue increases by monitoring our return on investment. Okay. Right. So here's just more details of what that terminology can look like in different areas. I could have a client need, functional specification, system, subsystem definition, component, and then I'd have a corresponding test model, component, validation, subsystem, system, functional, and then go into production. Okay, so you go top down, bottom up, and you're delivering the functionality that the business asked for. And this is exactly what you're doing with those different levels of your data modeling. Okay. Now, lots of time people ask, well, why don't I just go down to the physical data model with SQL and I start building the physical data model? Because you're going to have too many jumps, and you can discount certain people getting involved with your business requirements. And you're not going to get that, yes, we're in agreement. Yes, at that level, we're in agreement. Yes, I'm in this agreement. You go down to the bottom level with detailed design, and there's a whole lot of no's sitting here. And then you run a hiccup in your sprint, and then you're in all sorts of trouble. Then you've got pretty much like a waterfall design, and you got lots of challenges. It's not to say that it doesn't happen. Waterfall wants that to happen. And this is also used in mechanical development, where you're developing software and you're developing hardware at the same time. So I just wanted to take you through that. And then to go through this situation where we talk about specifications required for development. So this is our developers who are going to put the application together, or even the data warehouse or the data product together. And here again, it's this thing of functional versus non-functional requirements. What's the difference? A functional the requirement describe what the product does, and non-functional in terms of how it does it. Okay, how do we do this? What is the end result? Define the properties in the different requirements. And I'm seeing here's an example of these different things. So can you see a functional solution? The business want us to be able to display the customer last name as a link to the account history and allow a sorting by account open date. That's a subsystem or level of requirement. And then the non-functional requirement will be, well, I need up to 200 users to be doing this concurrently. That's what the requirement of the way the system should operate. Or I require strong passwords of at least 8 characters in length for people to be able to access this functionality. Okay. And can you see as well in terms of our specifications, right at the top, we've got the business requirement, reduce incorrectly processed orders by 50% by the end of the next quarter. Now that almost looks like a KPI or one of those things of an OKR in terms of a business performance measurement strategy. And then we get another one, increase repeat orders from the customer by 10%. So very high level business motivation. Then we come down to the user stakeholder. This is what we need the function, the system to do. Here we have functionality, non-functional, and then we go down to implementation. Now, I'm hoping you can see that the level of discussion and the level of essential details changes as you go down. And I find if you try to write all of this in the same document together, you'd probably lose the people and there wouldn't be an appropriate level of understanding. So this is what we refer to as that quest for good requirements. Business requirements, high-level needs, textual definition, that's great. Both functional and non-functional provided by the sponsors. And then you're going to come down to functional requirements, system specifications, detailed diagrams, and then created by the business analyst or the requirements engineer. Okay. All right, so if we look at basically the artifacts that are created during this process, this is what the analyst builds, context diagrams, use case models, and there we have our conceptual data models. The data dictionary is a little bit of I would have expected logical, physical, and then the data dictionary. User interface models, business process models, prioritized requirements, business rule catalog, and prototype. So these are all of the analysis artifacts across all of our different types of people, from our data modelers to our solution architect. these are all the things that we're trying to collect and build up in terms of defining the requirements. Okay. And again, here we have the different requirement documents, and we're seeing the detail as we're coming down. So I'm just going to show you what these specifications are that we're referring to. It's not so much about a coding interface and the background of implementation. It's more, how do we extract the requirements from the business and how do we implement their needs? Now, going into the last section, which is the data lifecycle management. I'm sure you guys, hopefully you've seen this in your fundamentals and in the DMBOK. And here is the data lifecycle of plan, design, create, store the data. Create is your data integration. Then you store the database, then you can use it in BI, you can enhance it on a data model, and you can dispose of the data. And a lot of the times you're going to get different specifications coming out at these levels. So your data architecture at a high level is going to be part of the planning. You're then going to pick up your conceptual model, your logical model, and your physical model. You'll then get into creating the database and storing. That's where your actual database comes in. Your data lineage or your data chain to handle that area. And so you're getting these different artifacts and different levels of detail at which you need to operate at. Okay. And what I like to do as well is, as part of this for my whole program, what I like to do is set up for the SDLC hierarchy. Again, this should be the data architect, and they should be defining by knowledge area in the DMBOK, what has data governance got to produce? So they've got to produce a business glossary. They've got to produce policies and procedures, a strategy. And then what does the data architect produce? What is the data modeler, the DBA, the data security, reference and master data? What have they got to produce? Data warehouse, metadata. And so each person has some form of specification that will be delivered at the different stages of the SDLC. Okay. And so there's a before and after type of activities that are going to be done by the different levels. And here you can see where we go from in the SDLC feasibility of the project that we're dealing on, the planning for the project, the requirements analysis. And I'm hoping you're seeing here again is just this level of appropriate detail that we need to operate at, but we can't do everything. For example, a data dictionary immediately. We've got to work through all of these steps. And here's at a design level, these are the different areas of the data lifecycle. All right, so I just wanted to pause there. That's sort of what I wanted to show you in terms of what does abstraction for specification mean? And I hope you can see these different levels of artifacts that need to be produced at different levels for different audiences and different levels of essential aspects that need to be communicated. Any comments, feedback? Thanks, Gushay. Gushay, did that answer your question in terms of coming down on those levels?
It did answer my question in terms of, but it doesn't answer my question in convincing my boss.
Oh.
Which is maybe a different question, maybe not in context of this, but yeah, to convince my boss, this is the way we should as a company start implementing stuff. Or, when we commit to a client, we need to kind of convince the client why we're following this methodology or framework.
Right.
And what is the value for the business? Because what you mentioned before is, why do we jump directly not to the physical design? So, I mean,
Right.
they want to, and the value is getting there through the process or like you've mentioned, of abstraction. So we need to the value that the time versus the value that is spent needs to be more, more outcoming. I haven't seen it, but maybe, as I said, this is just not, this is the conceptual, and this is the stuff that I've learned a lot from this. Thank you very much.
Yeah. So So you're right. So one would almost, for example, have to say, well, what benefit do we get at talking to the business at these different levels of details and getting the right sign-off? Okay, so why don't I just go to modular design, and whilst I'm designing the module, I can do my requirements analysis. I'm interpreting what you're saying,
Something
and
maybe
it's
just
about
sorry, and just maybe to
yes, sir.
add to that is, if I've got a budget for 10 million, so I can do 5 steps: acceptance testing, system integration, unit. So if I only got 5 million, so what do I do now? Which of those ones I can cut to still have a profitable, but maybe
Right.
not a high quality output?
Right. I understand what you're saying, and I suppose the answer would be, well, it's very similar to the agile discussion. It's not about throwing away important documentation or specifications. It's about the speed and the detail that you do it at. So
Yeah.
it comes back to that minimal viable product. So, if I can be doing these things, if I can be doing them in smaller iterations with smaller deliverables and better definitions, the argument about this approach would be more about how do I prevent the cost of putting into production and then having massive kickbacks at the end of the production that is not working, compared to ensuring that I'm testing each step of the way and each level of abstraction. I'm getting to the right audience to get agreement of what needs to be done and what needs to be implemented. So to me, there's two debates here. One is not to say, well, I'm going waterfall, and if I cut out a step, then I reduce my time. It would be more that iterative model, but then ensuring that you confirming the need and the definition, or that precise representation of what needs to be built from the right people.
100%.
So agile people always say it's not about throwing documentation away. It's about getting into all the gymnastics and trying to get everything defined up front. We can still go through these details of drilling through the detail of exposing the detail, but it's going to be smaller and faster. I think, yes. Renita.
Hi, Howard, how are you?
Yeah, right in yourself.
I'm good, thanks. Howard, more a comment than, and that is, as you had the functional and the characteristics, if this helps anybody. If you talk about Mercury, it has certain functions, a functional character,
Yes.
functionality about it, it freezes and so on. For anything, copper, any metal, anything on the
Right.
sort of reactor changes. I might observe it as orange, you might observe it as yellow.
Right. So yeah.
I don't know if that will help get into that as an analogy, but there's also the place where you then start amalgamating them, and I thought that was maybe just missed a little bit. When you start having reactions and you start having disparate systems or things come together, utilizing a catalyst. I found that you didn't quite maybe cover that when you start to add disparate systems, and maybe in this last bit of discussion on the integration.
Okay, so what I would like to
you.
share with you is the essential concepts that we spoke about last week. And one of the ones I wanted to talk to you about was, what we presented was the Zachman framework. And I was referring to these different levels of detail. And what was always important to us is to say, even though I'm working on data, at the same time, I'm working on the processes or the interactions that are happening, as well as the people, as well as the network, as well as the timing, specifications, and as well as the motivation. So I'm including all of these, but they're coming down in the levels of detail, and each one needs to be developed at the same time. and you'll branch them out similar to this type of scenario. So when I'm doing the system logic with this representation, I must do the corresponding process or interaction model with a corresponding organizational model, and all of those need to be checked as part of our processing. I'm hoping that answered your question, or did I miss it?
Thanks. No, perfect. I didn't attend last week, so apologies for that, but absolutely perfectly done. Thank you.
Yeah, no problems. Yeah, so that's a good thing. I should have actually included this step in there just to confirm that I am dealing with all of these aspects. So when you build all of it together, yes, I may be doing the data side, which is my area, but I need to be in sync with the process model. And there's another relationship where each data model links to the appropriate how model on that thing to understand what was going on. And so it's this type of thing. Yes, I'm focusing here and I'm going up and down my abstraction layer, but at the same time, I cannot be ignoring the process model on the left-hand side.
One more thing, Howard, what about disparities or whatever you want to call them within the data model itself?
And when you say disparities, are you saying that the definition of the entity or the attributes in the columns are disparate? What disparity are you referring to?
So is it possible functional or characteristics or something within the data that needs to be verified or validated?
Anita, I'm losing you. I didn't hear your whole question. Sorry about that. Is it just me?
Problem.
Yeah. So just if I could maybe say this is a disparity in terms of or almost a missing or like I'm trying to remember the programming term of that sort of semantic gap or what's the right term for it? That we mapping our meanings differently. Is that sort of what you're referring to? That we don't have the appropriate meaning or understanding of those meanings? Maybe if you could write it in the chat, Anita, that would be great. Okay. Excellent. Any other questions, comments?
Howard?
Okay, thanks. Thanks, everybody.
Sorry, Howard?
Yes, yes,
Sorry.
sir.
I was just thinking, and maybe so you've got your V model, which I think is awesome, the different levels and layers, and you mapping to the test, which is brilliant. Now, and then the second part was the business requirements, the different levels of requirement, making sure that the requirement brings in all those questions to make sure you cover everything.
Yes.
The top level of the V was the business requirement. So
Yeah.
the second set of slides, just checking that they all correlate, they all map to that business requirements analysis. You don't elaborate system design, architecture, model all the way down in your business requirement, or do you?
No, you don't, Paul. That's a very important thing. Is that then that's bringing in unnecessary details for the audience in which you're presenting, right?
Okay, got you.
You really got to stop yourself from getting into lots and lots of details, going too far. The people don't know what you're trying to ask them, and then they're worried about signing it off. And so you actually cause, there's that term of jy pluk 'n lat vir jou gat. and you just get whipped because you're adding too much information. You just
Okay.
gone overboard, and you
Yeah.
got to know when to stop. And that's what's important about this abstraction for specification. What are the core essential aspects of this system that I need to communicate and get agreement on? Anything else, it's wasting time. It's probably causing arguments, causing confusion, and you're in the wrong place.
Yeah. Okay. Cool. Cool.
And
Thanks.
also very good from a data model, Paul. Remember, we go that subject area model or data estate. Then we
Yes.
go to conceptual. So when you're just dealing at a data estate level and you want to understand data owners, don't start bringing in relationships and cardinality. Shucks, don't need it at the moment.
Yeah.
We're mutually exclusive and everybody's on their own. They're all focusing there. And then we go to conceptual. Then we understand, now how do these things relate? And if it's a dimensional model, how do we navigate on our drill down, on our pivot table? And so each thing has a meaning. Each thing has a reason with that describes the business requirements and business solution.
Yeah. Cool, man. And then I just saw on the other further down your where you're showing what artifacts must come out of each domain across the
Yeah.
data management lifecycle. Just saw your CDEs coming through there on data governance.
Yes.
And
Yes.
that was interesting because it's obvious it's a DQ topic, but bringing it nice and early into the.
Remember what we did with that DVD way, Paul, is that it was interesting when you do those use cases, you actually find those critical data elements coming out at this time, even before you start looking at data sets, right?
Yeah.
So your use case in terms of what it's trying to deliver in terms of value, they're already talking critical data elements.
No, very good, because like I said, normally it's a DQ subject or topic, but it's good to come through early because you're doing your business glossary and you're getting that definition quickly.
Right,
Yeah.
100%. And you'll see there, once we've agreed the critical data elements, that could be ratios or whatever it is, then we would get the corresponding DQ expectation.
Yeah. So you're getting your scope for your piece of work quickly and nice
100%.
and yeah.
And this is probably a term I haven't used, was that conceptual model. The other term is the business scope. Now, one of the problems we have and one of the dangers of abstraction at a conceptual model, it's really easy to add an entity that's not part of the scope. It's quick.
Yeah.
I got like 4 or 10, I got 4 objects, and then I can go to 10 objects, and next minute I've doubled, tripled the size of the implementation. So the more abstract the artifact is, the more problems you've got of controlling scope.
No, nice. And you also you obviously result in a nice tight strategy.
Yeah, correct.
Oh, cool. Thanks, man.
Alrighty. Okay, are there any other questions? Fantastic. Guys, thanks everybody. Thanks for the time. Thanks for spending time with us.
Fantastic, man. Awesome.
Wonderful evening.